Picture this. It is exactly noon in the ancient city of Thebes. The year is 1350 BCE, and the temperature outside is conservatively sitting at 43 degrees Celsius. For the Americans in the audience, that is a blistering 110 degrees Fahrenheit. The air is so incredibly dry that it feels like it is pulling the moisture straight out of your lungs with every single breath you take. There is no air conditioning anywhere. There are no electric fans. There is no ice. In fact, there is no cold drink of any kind anywhere on the planet, because mechanical refrigeration will not be invented for another 3,000 years. You are standing barefoot on sand that is hot enough to literally cook an egg on, living in a country that is 95% inhospitable desert. You are wearing nothing but a simple linen kilt, and in just a few minutes, you are about to go out into the blinding sun to do back-breaking manual labor. And the craziest part about all of this? You are completely fine. I do not mean fine as in you are miserable but bravely coping with the pain. I mean fine as in this is just a completely normal Tuesday. Fine as in you will do this again tomorrow, and the day after that, and you will likely live to be 60 years old, which for the ancient world is about as old as anyone gets. When we look back at ancient Egypt, we tend to get distracted by the shiny things. We see the great pyramids of Giza. We see the golden burial masks, the perfectly preserved mummies, and King Tutankhamun staring from a museum poster. But what we almost never see is the boring, relentless, brilliant daily engineering problem sitting underneath all of those monuments. Think about it carefully. How do you keep several million human beings alive, working, and not dying of massive heat stroke in one of the hottest inhabited places on Earth for 3 millennia, with absolutely zero electricity? Anybody can build a big triangle if they have enough rocks and enough time. But keeping that massive workforce alive long enough to finish it, that is the genuinely hard part. So today, we are going to tear down the shiny facade of ancient Egypt and look at the invisible survival engine running underneath it. We are going to look at the mudbrick architecture, the massive amounts of beer they drank, the ingenious wind catchers, and the strict necessity of salt. By the end of this video, you are going to realize something a little uncomfortable. The ancient Egyptians solved the problem of extreme heat so perfectly that we have basically spent the last century solving it worse, just with a lot more electricity. Let us start with the biggest misconception. We tend to imagine ancient Egyptians grimly surviving the heat, treating the desert like a hostile enemy. That is completely wrong. They were not fighting the sun. They had spent thousands of years engineering their entire civilization so thoroughly that the intense heat became a design parameter rather than a threat. Every single thing about Egyptian daily life, the shape of their houses, the fabric they wore, the exact timing of the workday, what they drank, was quietly, ruthlessly optimized to deal with one very specific problem. To understand how they pulled this off, we need to talk about sweat. Biologically, you are a walking evaporation machine. Your body cools down by pushing water out through your pores. When that water evaporates, it carries heat away with it. We are the most efficient sweaters in the animal kingdom, but that system runs on a consumable resource. In an Egyptian summer, you spend your internal water incredibly fast. A laborer can easily lose several liters of sweat a day. Lose 10% of your body weight in fluid, and you are dying confused, because heat exhaustion stops you from realizing anything is wrong. Furthermore, sweat is not pure water, it is salty. If you sweat hard enough, you can drink all the fresh water in the world and still crash because you flushed out the sodium your nervous system needs to function. This is hyponatremia, and it will kill you just as dead as dehydration. So, the fundamental survival equation in ancient Egypt comes down to 3 strict rules: reduce the heat load, replace the water, and replace the salt. Let us look at move number 1, the building itself as an air conditioner. When it comes to domestic architecture, the ancient Egyptians were quietly brilliant. Houses were built out of mud brick, Nile River silt mixed with chopped straw, baked hard in the blazing sun. Mud brick possesses a specific thermodynamic property called enormous thermal mass. A thick mud brick wall does not completely block heat, it delays it. When the blinding Egyptian sun hits the exterior wall all day, the heat slowly crawls through the dense material. Because of that delay, the absolute peak heat of the afternoon sun doesn't actually reach the inside of your living room until around midnight. By midnight, the desert air is freezing cold. You actually welcome that delayed wave of warmth. Then, the cycle reverses. The freezing cold of the desert night slowly crawls its way into the wall, arriving inside your house exactly at midday when you are desperate for relief. The mud brick wall is literally a time machine for temperature. They stacked other tricks on top of this. Windows were incredibly small and set high up on the wall to let hot air escape. The streets were narrow, so the buildings actively shaded each other. And during the hottest months, the entire population simply moved their beds up to the flat roof at night, escaping the trapped heat at street level to sleep under the cool, starlit sky. Which brings us to move number 2, the wind catcher. Many Egyptian houses, particularly wealthier ones, had a prominent architectural feature called a malkaf. It was a hooded, triangular vent built on the roof, intentionally angled north to catch the prevailing winds blowing down from the Mediterranean Sea. When that wind hits the scoop, it gets violently funneled down a vertical shaft directly into the living quarters below. Simultaneously, the hot air inside naturally rises and gets pushed out the high windows. You have essentially built a vacuum, a chimney that runs sideways. This is passive ventilation at its finest, running entirely without electricity. But the Egyptians took it one step further. Some households would take porous, unglazed clay jars, fill them with water, and place them directly inside the wind shaft. Water seeps through the porous clay. When the hot, dry wind hits it, the water evaporates instantly, forcefully pulling heat out of the air. By the time that breeze hits your living room, its temperature has dropped significantly. They essentially built a zero-electricity swamp cooler out of river mud, a fired pot, and a hole in the roof. Move number 3, linen, and why covering up beats stripping off. Your modern instinct in extreme heat is to wear as little clothing as possible. The Egyptian answer was more nuanced. Their clothing was almost universally linen. Linen fibers are hollow, so air moves freely through the weave. It is incredibly breathable. It wicks sweat directly off your skin to help it evaporate faster, and it does not trap body heat like wool or cotton. Furthermore, wearing loose, light-colored cloth over your body keeps you vastly cooler than walking around with bare skin because it acts as a physical shield. It physically blocks the brutal solar radiation from cooking your skin, while the loose fit still allows air to circulate. Being naked under the Egyptian sun does not give you freedom. It just gives you severe radiation burns. Move number 4, drink beer. Seriously, drink massive amounts of beer. If you are doing manual labor in the desert, you need several liters of liquid a day just to survive. The Nile River was right there, but it was full of abrasive silt, waste, and horrifying microscopic parasites like schistosomiasis. Drinking raw river water was a massive biological gamble. So, what did they do? They drank vast civilization-scale amounts of beer. This wasn't modern, crisp beer. Egyptian beer was incredibly thick, low in alcohol, and made by heavily fermenting baked loaves of barley or emmer wheat in water. It was so dense it was closer to a liquid porridge. It provided hydration, yes, but also dense calories, complex carbohydrates, and essential B vitamins. Crucially, the brewing process, the heating of the mash and the fermentation, created a liquid environment highly hostile to waterborne pathogens. Drinking this thick beer was significantly safer than drinking raw river water. It was so foundational that laborers were paid their daily wages in bread and beer. When workers at Deir el Medina didn't receive their beer ration on time, they staged the first recorded labor strike in human history. They walked off the job because cutting the beer ration was literally switching off the water supply for men doing heavy labor in a desert. Move number 5, accidental chemistry and the salt replacement strategy. You have replaced the water through beer. You have not replaced the salt. The ancient Egyptian diet handled this electrolyte deficit almost entirely by accident. Their staple food was coarse, dense bread, so gritty with desert sand that it visibly wore down their teeth. To supplement this, they heavily salted and dried fish pulled from the Nile to preserve it in the heat. Add to this a diet rich in potassium-heavy fruits like dates. Nobody in 1350 BCE was intentionally designing an optimal sports electrolyte strategy. But a daily diet built on heavily salted preserved fish, sandy bread, and potassium-rich dates, consumed alongside enormous volumes of beer, produces an end result that perfectly mirrors the exact fluid and mineral replacement therapy a modern sports physiologist would prescribe. Move number 6, just don't be outside. The Egyptian day was fundamentally structured around avoiding the sun, rather than aggressively fighting it. The heaviest physical labor happened in the crisp air of early dawn. By the time the sun reached its terrifying zenith in the middle of the day, creating the truly dangerous window of heat, the entire society essentially paused. This was the time for rest, seeking deep shade, and sleeping. Work resumed in the late afternoon as the shadows lengthened. They bent their entire society around the sun's schedule. And the grand twist of the story, the desert wasn't the problem. The desert was the point. For this entire video, we have treated the extreme heat as the enemy. But the truth is, ancient Egypt only existed for 3,000 years because of the desert. The brutal, waterless sand functioned as an impenetrable, continent-sized wall. It is the reason Egyptian culture remained stable while neighboring civilizations were constantly conquered. Invading armies simply cannot march across hundreds of kilometers of lethal sand. The desert was an infinite, deadly moat that the pharaohs never had to pay to build or maintain. Furthermore, the extreme aridity of the Egyptian desert is the single reason we know anything about this civilization today. Organic material rots incredibly fast in humidity, but survives forever in absolute dryness. Every intact papyrus scroll, every perfectly preserved mummified body exists because the exact same brutal climate that made daily life difficult made biological decay impossible. Even mummification was just an attempt to artificially reproduce what the hot, dry desert sand did for free. They didn't just survive the heat, they weaponized it. It defended their borders, preserved their archives, and dried their dead kings for eternity. Imagine a house in Thebes, 3,500 years ago. Thick mud walls silently holding yesterday's cold. A clay scoop grabbing the north wind. A sweating water jar cooling the breeze. A family asleep on the flat roof under a massive star-filled sky. Not one single part of that intricate survival system requires a power grid. It has no off switch. And it was arrived at by several thousand years of ordinary people paying very close attention to what made the afternoon bearable. Today, we try to solve the exact same problem by sticking a loud, buzzing machine in the window, cooling one room while pumping waste heat into the street and making the planet hotter. The ancient Egyptian laborer was running the exact same biological calculation that you run every single summer. They just did it with vastly better, more sustainable architecture and admittedly much thicker beer. Their answer to the environment was never macho toughness. It was mud, linen, shade, salt, and paying attention. Could you survive a full summer in ancient Thebes? No refrigerator, no electric fan, a flat roof for a bedroom, and a thick jar of warm beer for breakfast? Let me know down in the comments below, and if you enjoyed this video, hit that subscribe button. See you next time.